Hello. The Math 2 CDT team asked if I would make a video kind of giving you an overview of some of the changes that we've made in Unit 12 from what you did last year. If you were teaching Math 2 last year, you may remember that the book materials for Unit 12, Quadratics, did not match our test questions for Unit 12. Now, we did a limited version of Unit 12 last year because we were short on time. This year we're going to get to do the full unit, and we've broken it into two parts. There'll be a Unit 12a, it's one unit all by itself, and Unit 12b, it's one unit all by itself. But one thing I want to point out to you is the tests were written looking at the California state standards, making sure we were matching those, looking at Smarter Balanced released questions, making sure that we were asking the correct level and type of problem that students will be expected to do when they take the Smarter Balanced tests. And again, just peering deeply at the standards and trying to see what the content was that we really needed to be testing. The book did not match those questions once we wrote them. And so the CDT team at the end of last year's unit, and I think it was universal from every school site, said we need to make worksheets or something that get our kids ready, because they were not ready just by doing the book material from Unit 12. And so this year, particularly for the first part of the unit, we have walked away from a lot of what is in the book. There are a few sections where we could use the book, and instead we made some of our own materials to fit better with what we see in the standards and the things that kids are expected to know. And so I just want to give you an overview of how this fits together. You don't have a textbook to look at exactly, and so I wanted to give you something. So the unit is broken into two parts. Unit 12a, we're going to focus primarily on vertex form. When you look in the book, the very first section in Chapter 12 has standard form. We're not going to be focusing on standard form, we're going to be focusing on vertex form. In Unit 12b, then we will focus on standard form. We're giving them, and they will see vertex form again during that chapter, but we're giving them one at a time. And so that's a big difference. And as you see things, if you're just driving through the book, you might find yourself spending a lot of time on things that are not tested during the first unit, the Unit 12a. So let me just look with you at more specifically what's in Unit 12a and what's in Unit 12b. Unit 12a, the first lesson is about quadratic functions. That lesson will include equations not in vertex form, but with just an a and a c value. So things maybe that would look something like this: y equals 3x squared, y equals negative 2x squared minus 5. This kind of thing with an a and a c value. And they should learn that the shape that those make is a parabola. It goes down and back up. It decreases and then it increases, or increases and then decreases. They should be able to name the vertex. They should be able to tell you whether that vertex is a maximum or a minimum, and be able to give you the domain and range of that function. Your CDT team people have access to this worksheet. They'll be making one that's specific for your site. Let me see if I can focus this a little bit. I'm not sure if it'll autofocus for me. Give it a try. It's a little better. There are problems in this section that will work for this, but we've skipped over certain parts. Specifically, we've skipped over 17 through 26 and saved it for the next day. And so what you want is name the vertex, how is it facing, does the parabola have a maximum or a minimum, what is the domain and range of the function. And they should realize that the A is making the parabola skinnier or wider and deciding how it's facing. The C is shifting the parabola up and down. The way functions shift based on these constants added, this is an important standard that we're supposed to cover. Okay, from that, before we go on to vertex form, we're going to look at rates of change and compare linear, exponential, and quadratic. Now, students have done linear and exponential in Math 1. They actually did pretty well on this unit in Math 1. And so now they're going to compare, and they talked about what the average rate of change was. For a line, the rate of change is the same every time. The rate of change is just the slope of that line. It's going up 3 over 1, up 3 over 1. Every single consecutive integer value, it goes up 3 over 1, the same every time. That's what makes it linear. And the student in a table, students experience that adding 3 feeling. For an exponential, if it was in a table, they would experience multiplying by the same number every time. So 1 might give you 2, the next number plugged in might give you 4, then the next number might give you 8, then 16. So they would feel that I'm multiplying by 2 every time as I go down the table, and that's an exponential. Its rate of change is not linear, and if you take the slope between any 2 consecutive points, at first remember that an exponential graph looks something like this. If I took the slope between these 2 points, I would have something that's not very steep. But if later I took the slope between these 2 points, I'd have something a lot steeper. It doesn't have a constant rate of change like a line does. The slope changes as you go along. And so average rate of change is important. One of the standards that is in the California State Standards is for students to realize that over time an exponential function grows much faster than a quadratic function. And that is exactly a specific question that's asked in one of the assignment problems that we've picked out. And so sometimes you might think, oh, why do we need to do that, whatever. A lot of the problems are very specifically targeted to certain standards. So that rate of change is next. From there, they'll learn what the vertex form of the quadratic equation is, and they will eventually be expected to write that in transformation notation. So for instance, if the parabola was moving to the right 2 and up 5, then you might say that the original was here and the new one went to the right 2 and up 5, that transformation notation that they had in Math 1 and earlier in the year in Math 2. I don't think it asks for that on the worksheet that we have for this, but I am bringing that up to you because later in several a group activity and a review and then on the test, they will be asked to write it that way. So to me, it seems like a natural place to bring that in. So vertex form comes next. We'll still ask them during the vertex form worksheet about the domain and range and whether the function has a maximum or minimum in that, just to keep building that same idea. From there, we hope they know a lot about the graphs of quadratic functions, and we're going to have them modeling with quadratic functions. These will be word problems that primarily focus around equations that are already given. So the student is not doing their own modeling where they're writing an equation in this, but they're doing an awful lot of reading and interpreting. What is the x standing for here? What is the y standing for? Would this graph have a maximum or minimum according to the equation? What does that mean according to the situation that is being modeled? And they'll answer questions about the maximum or minimum. For instance, how high did the ball go before it started heading back down? How long did it take before the ball reached that height? So there's some modeling functions. And again, the main thing that we're working on there is their ability to make sense of the problem and understand it in the context of that situation. And so reading is a big piece that you're teaching right there. Then we'll have them solving quadratic equations by square rooting. Square rooting is the most natural way when you're in vertex form. If you have x minus 3 squared plus 5, instead of y equals, if you've made that equal 0 because you're trying to find the zeros or x-intercepts, then let's make that minus 5 just to make life easier. Then you would, let's make that a minus 25 just to make it really easy. Then you would add over the 25, square root, including the positive and the negative and I wanted that to be 25, so I'd get 5, and then add the 3 over. They should get 2 answers, and they should see that on the graph, that when I graph this function with a y equals x minus 3 squared minus 25, it hits where y equals 0 2 times. It hits the x-axis 2 times. So they're going to be solving by square rooting. They're going to be able to look at on the graph and see how that applies. We'll also connect with the modeling problem, because in this lesson all they were asked was things about the vertex or plugging in a certain value. And now we'll ask them, once that ball got up in the air, how long did it take till it came back to the ground? And the ground would be a time when the height would equal 0, and we would solve like that. So we'll have 2 or 3 questions at the end that will tie back to our modeling, just to keep it all connected. And the last thing is they could solve quadratic equations by factoring. To solve by factoring, first we would need it not in vertex form. So I would suggest a warm-up where you move vertex form into standard form. And we're starting to make the connection to the next chapter. Once you've done that, then they can factor and find those same x-intercepts. So anyway, that's what's going on with 12a. There's a lot of little things hiding in Unit 12. And so I encourage you, before you start the unit, to take a look at the test with your PLC. Take a look at this group activity. We may take the word review out. Some people were wanting to do it after 12.3. I was originally planning on it after 12.5, but it could actually, I think it'd be a nice block activity, so whatever day that lands for you, that might be when you want to do it. And it brings up all kinds of things about domain of range. Is this a solution? So you're having to remember those wording. Here's a place, can you see this? Yeah. Here's a place where you need to be able to write the translation rule. So there's lots of different things coming up in here that come up on the test. And as we were looking at it, some people were saying, hey, that never got asked before. And I was like, yeah, this is an important lesson. Don't think of it just as a review. There's a lot of little hidden things that are review from before. Here, this one compares a function in graphical form with a function in tabular form. And that's one of the specific standards, that students should be able to answer questions about functions given to them in 2 different forms, not just 2 graphs or 2 tables, but 1 in each form. Some students will do that by going ahead and plotting these points to answer. But if I ask you about the minimum value, on this one I see the minimum value is maybe about when the lowest the y value gets is at -1. That happens when x equals -2, but the minimum value is the y value. The lowest it gets is a -1. And I can find the minimum value for g without plotting, just because I see right there -25 is the minimum value. And so the minimum value of f is greater than the minimum value of g, because -1 is a lot bigger than -25. And so being able to deal with the functions in 2 different forms is hiding in here. Lots of things are hiding in here. Here's some more things about average rate of change. Here's a question about a modeling problem. And so there's lots of things in there. Make sure you look at those. They practice some of the things that are a little odd that aren't coming up in other places, like the meaning of the word solution. So I'm going to set those aside for now. That's 12a. 12b has a lot of very Algebra 2-ish stuff. There's completing the square. I would motivate this by how do we get something that's in standard form back to vertex form? We know how to multiply out and get from vertex to standard, but how do we go back? And completing the square will do that for them. Once it is in completed square form, then they can solve by square rooting, so they can use completing the square to make it a solve by square rooting problem. Quadratic formula is another way to handle if they can't factor and they don't want to complete the square. They could use quadratic formula to be able to solve. Sometimes when you're doing quadratic formula, you get negatives underneath the square root. and mathematicians have made a convention called imaginary numbers, or complex numbers that use imaginary numbers. And so we should be introducing students to the idea of I, standing for the square root of -1. We don't have to do every single thing about imaginary numbers, but they should be able to, when there's an I squared, change it to -1, combine like terms, and most importantly, understand that if you're going to have a negative under that square root, it means there's going to be no real solutions. And that means there's going to be no real x-intercepts. It will be a parabola that is either above the x-axis, never touching, or below the x-axis, never touching, if you're getting imaginary, if you're getting negatives under the square root. So you'd be getting complex solutions or imaginary solutions. So you don't have to use the word discriminant. Sometimes I think the test, like memorize these 3 things to test, if it's negative, if it's positive, becomes a list of things to memorize without really intuitively understanding what's going on. I know that you teach it so that they would understand it, but the word discriminant is nowhere in the standards. But what kids do need to understand is if there's no real solution, what is that graphically? What does that mean? And you might have them draw. How many solutions can you get? How many x-intercepts is it possible to get? Well, you can get 0, you could get 1 if it just barely touched, or you could get 2. How does that work out in the quadratic formula that we get 0, 1, or 2? How does that work out in factoring that we get 0, 1, or 2? How does that work out when you're solving by square rooting that you get 0, 1, or 2? And so those are all things to think about, deepen their understanding about those things. Better than just a list of rules. Linear, exponential, and quadratic models, we're going to actually get data and decide, does that data look, if we plot it on a graph, more linear, exponential, and quadratic? And we're going to have students, ideally you'll be able to have students on computers or shared on phones to be able to use Desmos and plot data and get a line of regression. This is going to be especially important for your juniors in your class that will be taking the SBAC, because they did not have that piece last year in Math 1. This year, Math 1 kids did have that, but last year they didn't, and they'll be taking a test on that, so they need to do that. So we're adding that in here to Math 2 also, and so you'll do a little piece on that. It is a tech piece. In a worst case scenario, where only 3 kids in your class have cell phones and you can't quite make it 1 per group or 1 per every 2, that can do it, you could model how it is done and have the students answer questions about it. Give them time to go home and use a computer device to be able to do that. If you have graphing calculators, it also can be done on that. And then the last thing that comes up in this chapter is systems of linear and quadratic functions. So if you have a line and a parabola and you're trying to find where they hit, and we'll have some graphical ones and some algebraic ones like that. And so that will be the end of Unit 12. Unit 12 is still a work in 12B is still a work in progress, but Unit 12A is for the most part done. We're fine-tuning the test and just making last little changes in that. So your PLC lead should be able to tell you all about what's going on there and get you any worksheets that we've made. If you have any other questions and there's not anybody else that's around to answer, feel free to email me, and I will try to get back to you as quickly as I can. Thank you and good luck.